All right, boys and girls, let's do another round of pen and paper, and today we're going to find the distance between two parallel lines. Well, let's draw what we have to the best of our ability, because that's all we ask. I'm going to make a coordinate plane, 4, 5, 1, 2, 3, 4, 5. I'm going to graph this guy in blue. So if I graph that guy in blue, I start out by going up 1, 2, 3, 4, put a dot, up 2, right 1, ran out of room, down 2, left 1, down 2, left 1. And once I have enough points where I feel comfortable graphing, I draw that line. I'm going to graph the other guy in red. I have -4, 1, 2, 3, 4 down there, up 1, 2, right 1, up 1, 2, right 1, or I can have gone down 2, left 1, and then that line is going to look like that. And as you can see, I drew two lines that are perfectly parallel, okay? So this is what I have to do. The distance between two lines that are parallel is going to be a perpendicular segment that connects both lines. So the first thing I need to do is I need to find an equation of a perpendicular segment. Okay, that's step number one. So this is what I'm going to do. I'm going to pick any of the two lines that I had, and I'll pick the one in blue. And I need to find a point living on that graph. All right? The easiest point to use is always when we let x equal 0. When x equals 0, I have y equals 2 times 0 plus 4, which gives me 4, and so that gives me the point 0, 4, which makes sense. Let's take a look at the blue line that we drew up here. I have a y-intercept of 0, 4, so a point on that blue line is 0, 4. So what I'm going to do is, what I'm trying to find is this perpendicular segment is going to be a line that's perpendicular, creates a 90-degree angle, and connects to that red line somewhere. Okay, so I need to find out what that green line is. And of course, there's an infinite amount of green lines that I could draw here, but the one that I created was when I let x equal 0. And we're usually going to want to let x equal 0 because it's just easier that way, to be honest. To be frank. My name's not Frank, but I'm going to be frank this one time. That's a joke. Now, if this is a perpendicular segment, then it's going to have a slope that's perpendicular to that blue line that I chose. So the perpendicular slope of a line, especially this line that is perpendicular to this blue, is going to be a negative reciprocal of that slope right there. Since that slope is 2, or 2 over 1, the negative reciprocal is going to be -1 over 2. So my equation that I have so far is y equals -1 over 2x plus, I don't know, plus b. Well, what does b stand for? The y-intercept. Well, if that green line goes through that point, and that point is the y-intercept, then that 4 is my y-intercept. That's why we always let x equal be 0. So now I can say that that green line, that perpendicular line segment's equation is y equals -1/2 x plus 4. Cool. That's step one. Step two is, now that I have this dot and I have that line, I need to come up with whatever that dot is. So I need to find where my green line and my red line intersect. In other words, I have to find where my perpendicular line that I just came up with and the other equation that I didn't use, this red one, I have to find where the perpendicular line and the other line intersect. How do I do that? Well, I make myself a system of equations. My perpendicular line was y equals negative 1/2 x plus 4. My other line was my other line, that was a close one, was y equals 2x minus 4. Now, we've been doing geometry for a minute now, and we know that if y equals this and y equals that, then the transitive property says, hey, just set them equal to each other, baby. Baby, just set them equal to each other, baby. And then I solve for x equals something, and once I find x, then I can use that to find my y. That's going to be the point where my green and my red line intersect. All right. So, why don't I start out by adding 1/2 x to both sides. 4 equals 2x's plus 1/2 an x is 2.5 x, or 5/2 x minus 4. Add 4 to both sides. That gives me 8 equals 5/2x. I'm going to multiply both sides by the reciprocal. And the reciprocal is 2/5. 2/5. And I end up with that awful number 16/5. That's going to be my x value. My x value is 16/5. Terrible, 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 terrible. But such is life. Now I have to find my y value. So let me use that red equation. It looks a little simpler. Y equals 2 times 16/5 instead of x minus 4. That gives me y equals 2 times 16 is 32/5. What I'm going to do is I'm going to quick turn 4 into something over 5. So 20/5 because I multiplied the top and the bottom by 5. That becomes y equals 12/5. So the point that I get here is the awful point 16/5. 12/5. For those of you decimal heads, that's, what is that, 3.2 and 2.2. You decimal heads out there. Just kidding. 3.2 and 2.4. Sorry, decimal heads. All right, that's step 2. I found another point. So the first point that I found was 0,4. So what color didn't I use yet? I don't think I used orange. Let me circle that. The other point that I found was that monster. My third step is to use the distance formula. On those 2 points. So let me write out those points again. 0,4 was the one that you can't see anymore. And 16/5, 12/5 is the other point. Distance formula. D equals big square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Maybe that square root was just a bit too big. Can we see everything? Yeah, now we can. I'm going to label my point x sub 1, y sub 1, x sub 2, y sub 2, gross. D equals the big square root of x sub 2 is 16/5 minus x sub 1 is 0. That's easy. Squared. Plus y sub 2, which is 12/5, minus y sub 1, which is 4. So instead of putting out 4, I'm going to put 20/5 because that's the same as 4. Just to make subtracting a little bit easier. Okay, that's supposed to be 4, but I made it 20 over 5 so that I can deal with fractions a little bit easier. All right, now I have 16 fifths squared plus negative 8 fifths squared. 16 squared. I think I know this, but I'm drawing a blank here. 16 squared is 256. I did know that. So what I have is 16 squared, which is 256, over 5 squared, which is 25, plus negative 8 squared, which is 64, over 25. Combine those guys. And what is that, 320 on the dot? Is it? It is. Ooh, 320 over 25. I don't think you could take the square root of 320. But why don't we just take the square root of the whole thing? Because most of the times when we deal with this, we're going to be asked to do decimals anyway. So I'm just going to type that away right now. We end up with 3.5777. You can't get much more perfect of a number than that. Awful. But look how pretty it is. That is how to find the distance between two parallel lines. It's a lot. Have fun. Bye.